Hello everyone, I'm Giuseppe Torre from Cobalt Image, and today we'll talk about emulation and white balance. The most important part of the legend of color signatures between different camera brands comes from the straight of the camera JPEG files. Different brands for different legend or color signature, important color signature. We all know about the Provia, Velvia, Astia, and even newer classic chrome, nostalgic neg, Real Ace, made by Fuji for their X and GFX line of cameras. Basically, they worked hard to be able to create a signature to be cooked straight away from the camera to their JPEGs. The same did lately Leica after the legendary JPEG signature of their M9, M8, M10. They started doing their looks downloaded by the app on their newer lines of camera with different purpose. I mean, you can see, you can check what they did on the Leica Bleach, Leica Silver, Leica Teal, the Brass, Chrome Classic. Basically, they did what Fuji did many years before. Ricoh as well. I mean, I think they started before Fuji, I'm not sure, with the GR first version, with their famous positive film, but also they expanded the line with the negative film and the newer for the GR4 cameras, Cinema Yellow, Cinema Green, and many others always included in the GR line camera, like bleach bypass, high contrast black and white, and cross processing with different filters included. Most experienced photographer will not forget about the famous Nikon color signature coming from their camera on the golden era of the D200 and followed by the D700, D3 and following models. Skin tone, different shades of skin tone compared to the other cameras were the signature of Nikon. All cooked in their JPEG engine inside the camera. And who forget the Canon picture styles. So basically Canon started believing on that many years ago with their EOS 5D Mark II, even the 5D Classic, I think was the first 5D Classic, applying their picture style, easy to personalize, to create, to upload inside the camera just for their internal JPEG engine. So here we are, 2026, we do color emulation with Cobalt. We are Cobalt and we are proud about our color emulation made following a scientific approach of colorimetric scientific approach. But the problem on that approach is that we comparing basically two different engines. If we start working from Ricoh, we basically have two different engines for the same picture. If I take this picture with the RAW and JPEG as well as an output, I'm basically doing the basic engine of the camera is working to create the pipeline for the final JPEG output 8-bit with the color style applied, cooked inside the camera. It's generating also the RAW. The RAW is clean, has to be processed by a RAW editor, as you can see, as you know. It could be Lightroom, could be Capture One, could be DxO, and many others. The JPEG is finalized. When you get an emulation, like our colorimetric emulation of, let's say, positive film like this picture, you will have a reference that is the positive film made by the camera inside the camera in the JPEG, and a RAW. That's the RAW with their temperature, tint, and all the setting reset as a starting point. So if we have the emulation, we can apply the emulation. We have the opportunity now, having the spectre emulation, I mean the emulation LUT applied on the spectre as a starting point, to work with a deterministic white balance. What I mean is, the picture has been taken on daylight illuminant, so I'm sure the daylight setting would be the perfect setting if I pick the positive film spectra. The camera itself did, as a shot, almost close to daylight. Yes, 5400. Daylight it's 55, with a big shift on purple on tint. If we put daylight, there we go. We have the proper white balance for the scene. I did explain before about the fact that the camera it's guessing the white balance with different level of precision between brands and between different models. So in that case, I would say almost nailed the right one with a shot. But as you can see, in that moment, in the pipeline, internal pipeline of the creating the JPEG with the positive film cooked inside the JPEG, the camera did a different job. If we open the JPEG, the first thing we see is they basically applied the correction of the lens, of course, so we should do the same on the RAW. Yeah, so the first thing we see is the different color signature. If we compare the two pictures side by side, we can see there's a big difference in color signature. Why this big difference? This is positive film and this is positive film. Maybe the emulation is not good enough. That's the first idea that approach in our mind if we see this difference. No, that's not the point. The point is the camera itself, in that case the GR4, as you can see from the description on top, did a different process for white balance between the internal engine of JPEG and the camera output writing the as shot setting on the RAW. We can see that if I edit the DNG white balance straight away, if I reduce, let's say 600 points, the white balance, and I keep the tint. I think the tint is online. Now you can see I wasn't wrong. The emulation is working perfectly. The problem is that we don't know that the camera behaves in that way. I mean, the camera creates a JPEG with a white balance and a DNG assigning a different white balance. We don't know, maybe that is connected with the color style, the picture style applied on the specific picture. Because the starting point of the DNG was very close to the real illuminant, the starting point of the JPEG wasn't. As we know now that the camera applied a lot more on metering for the temperature. Let's see another picture. First thing, profile correction. That profile is different. It's the negative film. Well, bit closer. As we see, it's a daylight, but we correct it. Even the camera on the RAW guessed almost perfectly. The white balance, we can put daylight to be sure, that's it. But if we see closer, still more yellow on the greens and on the street as well. Let's do the same correction we did before. Now there is a match. So yes, the GR, it's reducing the white balance matter by 600 points almost on these two pictures. So the correct way to work would be, let's say we split into the correct approach on that case. If we work with JPEG, we can set the daylight on the camera and shoot to be sure the picture style will be applied on a proper white balanced JPEG. Of course, we can shoot RAW and apply one on our profiles. On GR, the match as it is different, 600 points almost. What about the emulation made using the base profile and not the spectral profile? Using the base, as you know, means that we working with white balance in Adobe style white balance. So quite different approach. I mean, maybe not perfect if you want a perfect deterministic approach, but it's a different approach. As you see, the matter using the Adobe color profile gives us 4400 instead of 5500. So we do the same. We put the negative film, but this basic one. It's yellow, like used to be in the spectra, and we reduce him. This time maybe moving a bit, yeah, the tint. And we get the result, we get the match. So it's not about who's perfect, who's not perfect. If the emulation works or doesn't work. We calculate mathematically the emulation. So the LUT applied on a base profile or a spectral profile, it's, from our point of view, perfect. The delta E, it's very low. You can see any difference when the delta E between the two different output, it's lower than 2, 3, and we are a lot lower than 2. So the difference it's coming by the different pipeline of the workflow. One, it's internal of the camera, it's unknown to us. The other, it's in front of us with the raw editor. Could be Lightroom in that case, could be Capture One or the others where the LUT works. So important is to match the white balance. We are aware about how wide is the cover of our profile on the image, how extended we can cover the blues, the shade of blues, the reds, the shade of reds, the green, the shade of greens. We don't know about the choice made by the camera manufacturers, but we know that the output is a JPEG, 8-bit JPEG. If we work with a Fuji, let's say that's Fuji. That's Velvia on a GFX, as you can see. Fuji is more precise between the output of JPEG and the RAW with our color emulation applied. I show you right now. The white balance is almost exactly the same. Maybe there is a bit of difference, but some variables are impossible to be controlled by our pipeline. One of the variables is how wide is the how wide it's the gamut of the JPEG compared to the right side, the RAW. And we can see on this picture that it's not about white balance now. It's about the support we're using. On the right, on the left we have a JPEG, on the right we have a RAW. And the JPEG has been compressed, so it's basically compressing all the color we want in a smaller box. We have a wider box here where we can see more shades of color, and you can see from that picture the difference. JPEG and RAW, same picture, different white balance. We apply the Velvia. It's the difference I told you between different gamuts from a JPEG and a RAW are here. This is a JPEG, you can't edit anymore. This is a RAW, we can recover that. So you understand why, other than to be able to say if the emulation works well or not, this process of comparing JPEG from internal camera and the output or RAW output, it's useless, because that it's a finished picture, that it's a starting point. So our purpose is to match a starting point with the style we picked. In the case is Velvia. That is the picture, and maybe the white balance of the camera on the JPEG file wasn't perfect, because the white balance in that case it's daylight. So we're sure, because we have a spectrum that gives us this comfort by the deterministic white balance, that the camera, surrounded by the green on that specific picture, put a bit more purple on the tint of the internal pipeline to compensate the greens. On the right, we see the proper white balance of the scene. We can match it. We just have to move our sliders a bit to match it. But it's what we want. That's the point. Yeah. We can match the green, not keeping the posterization. Is not a posterization, we can recover it, but the sky can be the same, because that sky, it's almost in the corner of the box of the gamut of the JPEG. Here it is not even in the middle, because we can recover everything. So the colors of the internal pipeline are almost gone here. We are in the middle. We can do exactly what we want. That's to explain that white balance is very, very, very important in every scenario. This is a picture taken by M9. As you can see, this is the RAW, this is the JPEG with the standard color signature. Why I picked this picture? Because the legendary color coming from the CCD of the M9, it's legendary because the CCD, of course, the specific Kodak model, but also because Leica did a very good job on the internal pipeline for the JPEGs. Why I say it, good job for the internal pipeline? Because the color profile itself is not, it's a completely off to my point of view, the color profile made for the RAW, and the embedded as well is not giving us what we basically want. As you can see, the skin tone on JPEG has a typical fingerprint, the skin tone and embedded, so the profile put inside the DNG by Leica, it's far away, even we correct the white balance. We did an emulation on that specific camera, as you can see. But as before, the emulation needs to be tweaked a bit. So we have the as shot, but we have a lot more magenta, purple. We reduce the purple, we reduce the temp a bit, and basically we have a match. It's not a match just because we need to apply the color the profile correction, but we're close enough. Emulation works quite good. So it's important to recognize that someone can work with a JPEG only and understand the purpose. But if you work on RAW, you can check if the emulation is close to the JPEG, but you have to remember that the internal pipeline of the camera, whether it's the camera, Canon, Leica, Nikon, Sony, Fuji, Ricoh, Sigma, Pentax, use an internal pipeline that develop the JPEG with a particular contrast curve, the color signature of the picture profile, picture style, but also an internal white balance. And the white balance could be corrected. They don't tell us, I mean, us as Cobalt, us as a customer, what they do inside the camera. They just give us an output. It's an 8-bit JPEG. So when we want the color signature on our RAW, because we want to manage the white balance by ourselves, we want to correct it, we want to think about it maybe home and not just during the session. We want the freedom of the RAW, recovering, opening shadow, recovering highlights. That it's important to remember that our picture style for the RAW is on the starting point of a long process. So we can have the same color signature, but that color signature is applied on a different color space, on a different gamut, a lot wider, with a different white balance. So it's all about what we want and what we are able to do on our editing. Thank you very much. See you later.